Hello, I'm Nobby. Welcome to my workshop. Following this is part 12 of my PM Research engine build, but I wanted to take the opportunity to wish all of you a Merry Christmas and a happy and peaceful New Year. It's been a great year for me. Lots of things happening in the workshop, and starting the PM Research build probably a couple of months or more ago now. This is the longest project I've taken on for YouTube. In the past, I think my YouTube videos at the most have only ever been 2 parts, but as I say, this is part 12, and I think it would probably extend to 16 or possibly 17 parts in all, so there's still 4 or 5 parts still to follow, so I hope you'll stick with me. I was rather hoping to complete the engine build to show you before Christmas, but unfortunately that's not going to happen now, so you'll see that the final videos on this sort of early into the new year, where I hope the engine is going to run and I can actually show it running to you as well. But anyway, without further ado, let's get on with my weekly video for you. Bye for now. Bye. Hello, I'm Nobby. Welcome to my workshop. Still some work to do on the cylinder. The last job I did was drilling the bore hole through here, 1/2 inch, and drilling a 1/4 inch reamed hole here also for the piston valve. The next job I'm going to do is drill a hole through here, a 5/32 hole through into the bore. This would give you a sort of an air inlet. The obviously important thing is setting this up correctly. You would assume that you've got to drill a hole in the dead centre here. This is what I thought to start with, but of course I did a lot of checking as I was setting this up, and in fact you've obviously got to get it in the centre this way, but if you put it in the centre in this direction, it's actually not going to go into the centre of the borehole here. So what I did was I used my little pointer here and brought this down and then lined everything up very carefully to get it in line in this direction. And then to get it in the correct position here, I brought the pointer over here to make sure that it actually lined up to the centre of this hole here. Now also an important thing is obviously to get this little projection here in line, or in perfect line to the cylinder itself. So what I did was, when I was trying to line up to drill and ream these 2 holes, you can probably just about see it. I put a little mark on the centre here where the join is between the 2 halves of the cylinder casting, and the same this end, and then just put a reference mark along here, just literally with a Sharpie pen, so that I could line this up with the top here of the vise, and also to check then that this was level. A good way of doing it was using this. I've had this engineer square for a long time, because I guess when you would, this is obviously very, very old, when you would have bought this new, it would have had another piece of metal like this mounted into this slot here. So I've just found a an odd piece of scrap aluminium that has got a nice machined edge on here, and I've lined this up and then made sure that it is, you can actually see this, so to make sure that it is absolutely square here. And as a second means of checking that this is square, I put this onto the base of the mill vise to move that over the top. Actually need to raise that up a little bit out of the way to give me another visual check, sort of looking across here, that I have got that level as well, and that's okay. Pressing this down onto the base of the vise, I can see that I've got it level in this position as well. So I'm sort of quite happy that that's going to be okay. So what I can do now is just put a centre drill in here, mark that, and then drill through with the 5 30-second drill, and then the hole is tapped 3/16 40. That probably, I think that, yeah, that does relates to an ME drill, model engineering drill. These obviously are American planes, but I guess they use ME taps as well. I mean, luckily I have got a few sets of ME taps and dies in different sizes that I've used before. These were bought some years back when I made another engine on those planes. There were 2 different ME sized taps and dies required, so that's fortunate I didn't have to buy those as well. So I'm going to set up the centre drill and mark this and then drill it through, ready for tapping. Okay, I'm actually spot drilling this rather than using a centre drill. I'm sort of happier using these nowadays. Okay, that's gone all the way through there. Just double check that. Yeah, that's okay. Obviously I've got to be very careful not to drill too far through this and touch the other side of this reamed hole here, so be very, very cautious of that. So while everything is all set up, I'll tap the hole as well. There was another tapped hole required, and if you remember, when I drilled and reamed the 1/4-inch hole here, prior to that I had to drill all the way through the casting with the same drill size, the 5 30-second drill, so that when I drilled and reamed, I only had to drill and ream that 1 inch in, so that's up to sort of about this position here. And the 5/32 hole that's left this end, that also needed tapping with the 3/16 ME tap as well. But I have already done that. That was just a simple job of just tapping that little hole, because both of these will have little sort of screw-in pipes, if you like. I think they give them a name. They call them model pipe. So I've got to make those. That there's no material supplied for those. You just provide that yourself. So I'll make those out of brass. So there'll be a little pipe that screws in this side and that side, so that you can fit your air tube to it. Obviously, I'm going to be running this on compressed air, not steam. So I'm going to use a second tap to start with, but I'm going to have to use the bottoming tap to tap all the way through, because there's only a sort of small amount that you will be able to engage the cutting part of this tap into the hole. And also with the tap, got to be careful that I don't go too far through the hole and mark the opposite side of the reamed hole here. So I shall start this off as I normally do. Make sure that's nice and tight with the chuck here. So I'll get that. This is still not tight enough. I think it's just about gripped. It's to be tapping okay, but I've got to keep a watchful eye on the tap coming through here, that I don't go too far with this tap. I'm looking through the hole this way so that I can see what's going on. I think that's as far as I dare take that one, and I'll follow it up with the well, it's not really a proper bottoming tap. It's more just I don't know, third tap or plug tap. It's just basically what you get in the tap set. It's gone quite a long way through already, so. Very carefully set this in as square as I can. That's it. And again, I'll keep a watchful eye through the reamed hole. Hopefully that's okay. see what is going on through there. Let's get a torch and to see how close I am. That's really as far as I can take that. So, but obviously the threaded part of the little pipe I can make that a suitable length, so that obviously that's got to be made a suitable length so it doesn't go anywhere near the hole here. And then I obviously have to put the reamer in here just to clean up the inside. Okay, so that's that part done. So, saving the most difficult part till last. So we've got our two drilled and reamed holes here. We've got our, prior to drilling and reaming here, we drilled through with a 5/32 drill, and if you can see that I've got a thread in here already, and now I've got the thread in the top here as well, so I just need to do a little bit of cleaning up and make sure that the bored hole is lovely and clean as well. So there's just one job left on this now, and that's going to be drilling 2 holes down from here to a set distance, and then drilling an angled hole from the side of the bore here to intersect with that drilled hole as well. So that'll be the next job I'll do, and obviously bring you back for that as well. The next job is to drill 2 holes through here, one here and one here, and they are, it's a 3/32 drill, and that's drilled down 11/16 deep, so that the drill will come down to in relation to the borehole here, about that position here. So it's going to be about here on the casting, and then later the next job will be drilling in from here at a 20-degree angle to intersect that drilled hole there. So I've set this up to get it as square as possible. I've used my engineer square to line that up, and also make sure that the centre of this is in this direction, it is lined up correctly as well. And I've marked where the 2 holes are going to be. So I've used as usual my little pointer here to line up the hole in both directions. So I can replace this drill with a spotting drill. And then once I've spotted that position, to drill through with the 3/32 drill. I mean, obviously I could use the DRO to measure the depth I've got to drill down to, but what I've decided to do is take a different approach. I know this is perhaps not the most professional way of doing it, but I very, very carefully measured out the 11/16 here and put some tape on it. I had put a little Sharpie mark on here as well as a reference, but I didn't think that would show up well enough, so if I sort of drill down to that position, I'm hoping that will do the job well. So with that lined up here, the drill is coming down to about that position there. Obviously you just can't overshoot that depth and go into the bore, so you see there's not a lot of room for error in doing this, so it's got to be done obviously very, very carefully. So let's get going with this. Make sure all that looks as though it lines up nicely. And put another drill in. Nope. A slight problem I've found already. This drill chuck won't close down enough to take these small drills, so bear with me while I put a smaller chuck in here. Okay, I've switched the chuck over, you see, to a much smaller one. It's handy to have a small drill chuck like this available as well. So let's bring that back down again so you can see what's going on. And away we go. Okay, that's that one. Let's get that one done. Obviously you've got to take up a lot of care with this because you're also drilling through this bored hole as well, so you've got to be very, very, very careful how you're doing this. So have a look through there with my torch. Appears to have gone okay, so I can move over to here and drill the other hole. As it's exactly the same, I'll do that off camera and bring you back. Well, actually, before I drill that one, there is another operation. I've changed drill sizes here to a 2.6mm drill, because that only needs to be drilled in an eighth. It's an eighth of an inch, I think that is. Yeah, 1/8 of an inch deep. Because that tiny little 1/8 of an inch hole there is actually tapped to take a tiny little grub screw. So once all this everything is set up, the little grub screws there will cap off those holes here. So I'll just do that little counterbore with that little drill as well. It's very little difference. It's just taken the tiniest little bit out, the difference between those two drills, but there we are. So I will bring you back. Okay, so that's those two little holes drilled now. So what I've got to do is search through, make sure I've got a suitable 5BA tap to tap that hole there, which is only as I say 1/8 of an inch deep, but I'll probably just do that bit off camera. So the only process after this literally is setting this up to drill up through here, through that corner there, to intersect with these holes on both sides. So that's going to be the next job along, and that will then complete this part after that. I mean, so far it's been quite a nerve-wracking thing, but I think actually drilling the holes, which also give you an air intake position on each side of the main bored hole through here, is probably the worst part of the whole build, really, because that's going to be quite a difficult thing to do. I mean, I have done this sort of air intake system before on another engine I built, and that all went okay, so I'm hoping this is going to go the same way as well, but we'll see how we get on with that. So I'll bring you back. Well, this is the final operation on the cylinder. Is drilling a hole through here to coincide with the hole that goes through this part here. So this is basically forms the air port and exhaust into the cylinder itself. The first thing that's required is drilling a little counterbore first. That does two things. The counterbore will cut into the wall of the cylinder here and give a means for air to pass through the inner hole here and into the top and bottom of the cylinder. Also, it would normally give you a flat surface here to enable you to drill through. Thing is that ideally, I guess this should be done with a 2-flute end mill, so that you get a completely flat bottom to this, but the size that they suggest that you counterbore this, I'll just get my plans, is 3/32. 5/32 counterbore and a 3/32 drill. So I did a few sort of dry runs at this. I had a piece of metal here which had been drilled for something else with a 1/2-inch hole, and I did a few tests on it to get the right position for the end mill here to make the counterbore, and also you probably can't see this, you end up with like a little nub in the centre created by the end mill to make sure that could be machined away. I think this was the only one in the end that sort of worked out fine and gave me an idea of the ideal position to make the counterbore and so forth. You make the counterbore down approximately 3/32 of an inch. So let's proceed. We'll have a go and see how we get on. So I look through my magnifier. I think that's got it. Yeah, I think that's okay. So then you can see that I was running that down very slowly, because what I'm actually doing is using the fine feed to do this. I think trying to bring the end mill down using the hand wheel on the mill is just too fierce for it. Now I've got to bring the centre drill down very, very gently to sort of get rid of that little nub first. I did try using a spotting drill, but the nub tended to push this to one side slightly, so this drill's overall is much thicker, although it's a very fine point. So this should do a better job, and I'm going to push this drill into the chuck as far as it will go, so that there's sort of less chance of any movement on that centre drill. And again, I'll bring this down under fine feed as well, so I can lock the just hope that's I think that's it should be enough to guide the drill in, I hope. Let's take that out and replace it with the drill. So I'm drilling the 3/32 pole, and I'm drilling in 7/16. Just check that I've got that okay there. It's 7/16. But doing so much of this really by eye and by touch. When the hole, obviously that other hole is a, sort of across here. When this breaks through into that, you should be able to feel that happen. So I've put some tape round here to give me a guide. Not bothering to use the DRO for this, and I'm going to feed this in by hand this time. actually think I'm through now. Now, one way of checking this is to pop a bit of wire into the hole and a bit of wire into that hole, and you see it moves. So that bit of wire in there, and if I push that into that hole, you see that moves. So we've made contact. Okay, so it is through. So that now gives me that air path through and up through here. Let's take that drill out so I don't stab myself with it. Okay, so find a nice block. There we go. Let's take that out. So that's it. We've got our hole through. I'll bring this round to the camera. So we've got our little counterbore here. A little counterbore, which would have given me a flat if I'd had a 2-flute end mill, but I don't have one in that size. And it gives you a little path here, so the air will come through this hole and into the cylinder. And you see I've already done the other end. I did this first. This was obviously my test to make sure I was going to get it right before I committed it to the camera. So that's it basically. That's the final job on this this part. So the cylinder is now complete. The counterbore here has to be also machined in far enough so that when the end caps go on each end, there's a little step in the end caps to register into the bore. So you've got to make sure that it's a very, very fine measurement. I think it's only about a 30/2 of an inch deep, so that when that pops in there, it still gives enough space for air to come through into the cylinder at either end, or one end being the exhaust as well. So that basically completes this little exercise on this. So now I can move on to one of the other parts now. So there we are. That's it for this little episode. So thanks for joining me in the workshop again as usual, and thanks again to all the subscribers and comments I'm receiving as well, and look forward to seeing you in the next video along. Bye bye for now.